Okay, before I define what is meant by the composition of two functions, I want to remind you of something. Suppose f of x is the function 2x squared minus 3x plus 1. To find f of 2, what I do is I take the number 2 and I plug it in for the x's in f of x. So that's 2 times 2 squared minus 3 times 2 plus 1. So that's 2 times 4, which is 8, minus 3 times 2, which is 6, plus 1, and so that's equal to 3. Similarly, f of 1 is found by taking the number 1 and plugging it in for each x. So I get 2 times 1 squared minus 3 times 1 plus 1. 2 times 1 squared is 2, minus 3 times 1 plus 1, and that's 2 minus 3, which is negative 1, plus 1, which is 0. All right, that leads me to defining what is meant by the composition of two functions. The composition of the function f of x and the function g of x is another function f of g of x. So what I do is I take the function g of x and it becomes my input for f. So rather than having a number as your input for f, you're going to have an entirely different function. Let's do a specific example. So let f of x be this function, and let g of x be 1 minus x. We're going to find f of g of x, the composition of the function f and the function g. Okay, well this is just equal to f of 1 minus x, since g of x is equal to 1 minus x. To get this function, we take 1 minus x and plug it in for each of these x's. So it's 3 times 1 minus x squared minus 1 minus x minus 2. And then we just clean this up. 1 minus x quantity squared we find by FOILing, and that's 1 minus 2x plus x squared. Distribute the negative, minus 1 plus x minus 2. Distribute the 3. And so finally we have 3x squared minus 6x plus x, which is minus 5x. Then we have 3 minus 1 minus 2, and that's 0. So that means that f of g of x is equal to 3x squared minus 5x. Okay, let me give you one to try. Press pause while you work on it. Okay, so what you should do is you should take the function g of x, which is the square root of x plus 1, and plug it in for each of these x's. So we get the square root of x plus 1 squared minus 4 times the square root of x plus 1 plus 5. The square root of x plus 1 quantity squared is x plus 1. This can't be simplified, so we have minus 4 square root of x plus 1 plus 5. We can combine the 1 and the 5. So we have x plus 6 minus 4 square root of x plus 1. Okay, in some books you're going to see another way of writing the function f of g of x. Okay, this composite function. And it's written with the f circle g of x. Okay, so f circle g of x means the exact same thing as f of g of x. Okay, let's do one more example. Okay, so let f of x be 1 over 3x minus 5, and let g of x equal 2x squared plus 1. Find the function f of g of x. Okay, f of g of x, again, is f of g of x, written this way. And g of x is just 2x squared plus 1, so it's f of 2x squared plus 1. So all we do is we take this 2x squared plus 1, plug it in for that x. So we get 1 over 3 times the quantity 2x squared plus 1 minus 5. So that's 1 divided by 6x squared plus 3 minus 5. So that's 1 divided by 6x squared minus 2. So that's what f of g of x is in this case. Okay, for that same problem, find the composition function g of f of x. So in this case, f of x is the one that becomes the input. So we have to take f of x and plug it in for that x there. So we get 2 times 1 over 3x minus 5 squared plus 1. So that's just written as, to square a fraction, we square the numerator, which is 1, over the square of the denominator, 3x minus 5, quantity squared, plus 1. 2 times 1 over 3x minus 5 squared is 2 over 3x minus 5 squared, and then we have the plus 1. So this right here is g of f of x. So you see that in general, g of f is different from f of g.